Well, thanks everyone for coming, and thanks everyone who's here virtually. I will try to communicate with you as best I can through the camera. We were invited here today to give you guys a little bit of a workshop on science communication and how to give elevator pitches. So just to start off, if this is going to work, maybe my computer's being slow. I just wanted to just do a really quick introduction on who we are and who's here, so you have a little bit more, know a little bit more about us. So this event is sponsored by STROBE. We are an NSF Science and Technology Center, and we work in all areas of imaging science across 7 campuses, and we're working to build the microscopes of tomorrow, basically. In addition, we are working with students of all ages to give them pathways into STEM and to be able to train students for 21st century careers, which is one of the reasons why we are excited about working with FRIPS and being able to do the science communications seminar for you guys, workshop for you guys. So I am Sarah Schreiner. I'm the Assistant Director of Outreach for STROBE, and Ellen, who's going to be working the computers for me, she is Ellen Keister. She is the Associate Director of Education for STROBE, and together we run all the education events, along with Nico, who's connected virtually today. And so just a little background on myself and why I'm running this is, as a graduate student, I started realizing that a career at the bench was not the right career for me. Maybe some of you guys have started realizing this yourself or have gone down this path, and I got really into communicating science to the public, and so I spent a lot of time organizing events for the public, in particular public lecture series where I train scientists on how to talk to the public. I've been trained through the L&L, the Center for Science Communication. I've been trained through by Joe Palka from NPR Science Communicator, and Bob Bazell. I've done training with Bob Bazell, who is a CBS News correspondent. So that I did in graduate school, so it became a big part of my passion. I continued it as a postdoc, started a public lecture series as a postdoc at CU Anschutz, and now I'm doing what I can as my job as Assistant Director of Outreach. So. And then just one technical detail for the remote participants. We know that this is a webinar and there's people from all across Colorado joining. This is a very active workshop, and we want you guys to be able to participate as well. It'll be a little bit more challenging, but on Zoom, there is a chat on Zoom. And if you guys want to talk to us or communicate to us at all, please chat in the chat and answer responses in the chat, and Ellen will read them off to me, and so you guys can participate through that. That is what we found is one of the easier ways. You can also unmute yourself and talk into your microphone, but that sometimes causes some audio difficulties, but we can try that as well if you really want to communicate that way. But the easiest way is to chat through the chat on Zoom, and Ellen will read them. Okay, so like I said, this is a workshop for you guys to participate in. So I want to start off is, what is science communication? I want you guys to tell me what you think science communication is. Through the chat or here in person? Yeah. So explaining your research or what you're doing to a general public. That's definitely one of the aspects of science communication. What else is science communication? Yeah. Communicating with your peers, definitely. Yes. What do you guys do to get your science out to other scientists? You write research papers, right? That's a form of science communication. So it can span all the way from to the public to literally what you have to do to get promoted and tenure and everything is publish papers. Yes, that's very important. So this distilling results down to a few important points is another aspect of science communication. So here's the list that I've come up with and used over the years. So engaging the public, so talking to science communication is for the public, collaborating across disciplines. I don't know what all disciplines are being represented today. I know during my PhD, I am a biologist by training, but I actually did a biomechanics project, and so I was collaborating with physicists. And actually the communication barrier between biologists and physicists was extremely high, and I had to learn how to communicate across that barrier. Interacting with news and media so that you don't get crazy things in the news published about science that aren't true. Talking with policymakers, which is extremely important. Gaining support from funding agencies, so being able to know who your funding agency is and what they think is important, and knowing what aspects of that. And then again, writing the scientific papers in the science communication that you typically learn during your PhD. And so today I'm primarily going to focus on with the public and general audiences, because that's what you don't get training for during your PhD. The rest of it, especially the funding agencies and your scientific papers, you should get that training in your research lab. Okay, so that's all the different aspects of science communication. So why does communication? Yeah. Have a more informed public and electorate, yes. It's one of the big ones. Make people understand why science is important, yes. Yes, to be able to get funding. To be able to get jobs, right? Being able to communicate your science to all audiences to get jobs. So if I put up that list, it's pretty much the exact same list as what science communication is. Why is it important? Because it's important to communicate at all these levels. So we don't have the issues that we're having in the news today that you hear about with climate change, GMOs, vaccines, all these things where there is a scientific consensus, but the public may not agree with that. And also, yeah, for your own personal, get funding to be able to advance your career, to be able to get a job, all those reasons. Okay, so clearly, scientists can make improvements on being able to communicate. So again, I'm going to focus on a general audience, and scientists can make improvements on their ability to communicate to a general audience. But first, why is it so hard? I want to talk about why it's so hard to communicate to a general audience. Yeah. Jargon, yes. So that's one of the big reasons is we are used to speaking in jargon. So actually, I want to do an interactive game with you guys. So one of you guys from this room, or Ellen, if she was willing to volunteer, one of you, be a volunteer to come on up. You want to come up? Okay. And so I'm hoping that this will work. We tested it out before. So what I'm going to have you do is I have a list of songs on this. You're going to pick out one song, and you're going to tap it. There's no humming, no snapping, no clapping, just tap it on the table. And everyone, people connected remotely and you guys in the room, have to guess what the song is. So how I chose these songs, just so everyone is aware, I went on to Google and Googled most recognizable songs. So it's in the list of top 20 most recognizable songs. And then I tapped them out myself, and I'm not that musically inclined, so I made sure that I could actually tap them out. And so Bohemian Rhapsody was one of them. I did not choose that one because that's impossible. But so, and just let me know which one you choose. That one, okay. So I'm just gonna put the microphone here. Just keep repeating the bell here. It's not an easy exercise for anyone. I heard a no. So if I give you the decade, would that help? No? It's in a movie. It's from a movie. So I will tell you, since no one, I'm gonna this back. No, you can stay up here for a second. All right, so it was Pretty Woman. So I'm gonna have you tap it again and everyone listen to it again, and can you hear it? not everyone can hear it the second. Most people can hear it the second time once you know what the song is. Not everyone can. But for those of you that could hear it, so what do you think the point of this exercise was in thinking about why is it hard to communicate science to the public?
I know what I was trying to do, but since no one else in my brain or my field, I have no idea.
Yes. And then, yeah.
Someone said your view is not the same as someone else's.
Yeah, your view is not the same as someone else's view. So you have all this knowledge about your field, your subject, everything, but they don't have that. And it's just very challenging to get that to someone else. But then once you guys knew what the song was it easier? Suddenly you could understand what he was trying to communicate. So yeah, this is where there's this block of we have knowledge, the other person doesn't. That's not to say that trying to just throw facts at people is the way to go. That's not the way to go. But this is where the challenge comes up. And actually, there have been studies done on this. So I will read this out to you guys because I know it's a lot of text on the slide. But this is from an article from The Atlantic where they were citing a study, a cognitive science study about this. So Pinker, a cognitive scientist, says it boils down to brain training. The years of deep study required of academics to become specialists in their chosen fields actually works against them in being able to unpack the complicated ideas in a coherent, concrete manner suitable for average folks. Translation, experts find it really hard to be simple and straightforward when writing about their expertise. So this is about writing. So yes, it's very hard because we're trained to do it differently and we have all this knowledge. So Pinker calls this the curse of knowledge and says academics aren't aware they're doing it or properly trained to identify their blind spots when they know too much and struggle to ascertain what others know. In other words, it's sometimes simply more intellectually challenging to write clearly. So if you guys are having a hard time communicating to the public, it's because it's very hard. We have a lot of knowledge and we don't know what they know. And that's one of the biggest aspects and one of the biggest challenges when you think about science communication. And how we are trained actually to communicate and how we actually think about communicating is different than what the public thinks about. So there's a disconnect between how we think and how they think. So as scientists, if you think of any scientific publication, you start with background, you start with reason and rationale why you're doing the project, and then you get into your results and details. Unless there are other, obviously there's exceptions to everything, but in general, you talk about why you want to do this, you talk about, you give a background on your subject, and then again, you give the details at the end. At least every article I've ever written has always been results and conclusion at the end of the paper, not at the beginning. And so this is how we think. We think we have to give background details. So how do you guys think the public thinks about this? I already gave you a little hint on the shape of the air, They want the results first. They actually do care. They don't care why we're specifically motivated, but they care about the so what and why it's important to them, and they don't care about the details. So whereas we're hesitant to give off the big picture immediately whenever we talk about our science. We don't want to say the big result at the very end. When you talk about to the public or general audience, you want to tell them exactly your big thing right away. Okay. So how can you do that effectively? So you can tell them your result right away, but there's an effective way to do it in thinking about how the general public thinks. And so what do you think is one of the biggest things for if you're communicating effectively to the general public to be able to do this effectively? Yeah, distressing the application. So that kind of means like the so what, why does this matter? Yeah. And so how can you get to the so what and why does this matter for who you're talking to? Yes, there you go, exactly. Know your audience. So the bottom line, biggest thing is know your audience. And then once you know them, you have 1 minute to engage them. And after that, if you haven't engaged them in 1 minute, likely they're not going to be interested in what you're talking about. And so how you do that is you start with the big picture. You start with why should they care? Why is this important? And then you go into the details. Because once you got them engaged, you can go into the details. I'm not saying go into the details with general audience, like that's important, but you have to get them engaged first. And then, yeah, so this all basically repeats the same thing. Basically, find the so what, why should they care, what's interesting, and the big picture about your research. So how you determine the so what in the bottom line, again, knowing your audience. So I have another game, and either someone remotely can also play this game, or someone in the room, either way, if someone wants to volunteer. I promise you're not tapping music this time. Or we can do this as a group. We can do it as a group if you guys are more comfortable. Okay. All right, so I'm gonna put up different pictures of different types of audience members. It doesn't matter what your research is. Think about, what does this person in this position care about? So, politician. What would a politician, if you're talking to a politician, what would they care about? Public health, policy, funding, votes. Yeah, votes. What their constituents think. Yeah, so these are, if you're speaking to a politician, like just knowing this audience, you're talking about in those. So with the so what of your research is framed in that context, not in the context of like, oh, this is really cool. Think about like, how can this improve their constituents? How can this get them more votes? That sort of thing. Okay, a doctor, medical doctor. Cure disease, yes. In thinking about non-biological, like new technologies, maybe that.
Public health, how research helps their patients.
Yeah, public health, how research helps their patients. Yep, cutting edge techniques and new surgeries or something, other things that they can benefit from. New medication, yep. So you're getting the picture, okay. What about a child?
It's cool.
It's cool, yeah. Shiny.
How the research helps tickle their imagination.
Yeah, tickle their imagination. Okay, and how about grandparents? That's my grandparents, but what do you think your grandparents would care about? What's the best for the, yeah, what's the best for the grandkids, how they can live longer, live a better life. Okay, so this is just a little bit of a thought exercise to like, who you're talking to really matters on how you frame your arguments and how you frame what you're talking about.
How we can support ourselves after graduation.
How we can support ourselves after graduation. Okay. So now I'm going to go into actual practical so you guys can start getting some practice on this yourself. So how to actually communicate effectively. So the first step is define your audience. For you guys are here for FRIPS, which is for you guys are, your audience is going to be primarily industry, scientists who may or may not be in your field. So general scientific audience. So what do you think would be the level that you would want to talk to a general scientific audience? What do you think they might care about?
What the big picture is and what your question fits into the big picture and what you're trying to answer.
So what the big picture is and how your question fits into the big picture and how you're trying to answer. Okay.
So technical enough, but not using typical jargon.
Technical enough, but not using typical jargon. And global impacts. Real life applications of your research. So think about that when you're thinking about creating an elevator pitch for FRIPS, is these sorts of things about your audience. Okay, so this is just my general list of rules for when you're talking to a general audience. These are not set in stone, and you'll hear here when I give my elevator pitch, I don't follow these to a T either, but these are just general rules and takeaways. Again, the biggest thing is know your audience, know what they care about, and address everything to their level and what they think about. That helps you, once you can define what they might know, that helps you figure out what level you need to talk to. And one of the biggest things, especially in an elevator pitch where you have 1 minute to 3 at max, you get one takeaway that you want them to walk away with. So when you're thinking about talking to someone, what's the one thing that you want them to walk away from? And walk away from with your talk. And when I do it, I personally put the one thing I want them to walk away from like at the very beginning. Like that's my big result. That's the thing I want. That's just my personal way of doing it. Again, as long as that's within the first minute when you're talking. And if appropriate, think of a useful analogy, because that really helps people be able to picture what you're doing. And when you hear my elevator pitch, I'll give you'll hear I come up with a full analogy for my research to be able to communicate to a general audience, because it helps people picture it. And then if you can, again, these are just general ideas, but think of a fun lead-in sentence that draws your audience in. Don't just start with like, I can't even think of an example off the top of my head, but just think of something fun and poppy and exciting that draws them in, that makes them go, oh, I didn't know that, or oh, that could be interesting. Okay, so examples of elevator pitches. So I'm going to talk to you as if you guys, so I'm going to give you a really bad example of an elevator pitch from my research as a PhD student, and then I'll give you a kind of mediocre one, and then I'll give you my standard elevator pitch. I'm doing this to a general audience, so assuming my audience is a general audience. And just for you guys, for your knowledge, when I assume a general audience, I assume about high school level of education. So that's usually pretty appropriate. Unless you know you're talking to kids, assume about high school level. So my bad elevator pitch, my bad elevator pitch. So as a PhD student, I studied how chromatin at the nuclear periphery affected the mechanical properties of the cell. In particular, I was interested in internuclear membrane proteins and how if I knock them out in yeast, if I affect the nuclear shape and nuclear mechanics of it by developing a, okay, I'm gonna stop there. I'm gonna stop there. Yeah, if you were in my field, so again, I said I'm a biologist, I'm a cell biologist. So if you were in my field, you could probably understand that. But if you're not in my field, that probably just went over your head. And I could continue on with that. I could continue on. I don't actually have a practice. I do have used to have a practice short pitch for like a scientific audience, but don't anymore. So intermediate one would be like, oh, hey, I study how chromatin in your cells can actually act like a structural element in your cells, and how its organization is actually important for when forces from other cells apply mechanical stresses onto the cell to be able to maintain the overall structure of the cell. Something like that. Still jargony, getting a little bit better, but not great. So my actual elevator pitch that I have from my PhD research is, so I study how a new role for DNA in your cells. Did you know it can do more than just express your genes? So yeah, your DNA can act like the skeleton of your body, like in your cells. So if you think about your skeleton in your body, what is it? It allows you to stand up, it gives you structure. It's the main support system of your body. If you have a broken bone, or if you have a disease that causes a degeneration of your skeleton, you can't walk, you can't really function like normal. Well, the same thing for your DNA in your cells. So I discovered in my PhD that if your DNA in your cells is actually organized weird, your cells act the same way as if you had a broken bone. They can't function properly. And this actually has implications for heart disease and for muscular dystrophies. So again, I don't follow all of my rules perfectly, but I have an analogy so you have a better idea of what the heck I'm actually trying to do and trying to study. And then I actually leave the health implications at the end. I don't put it at the beginning, because the big takeaway point that I actually want you to know is I study a new role of DNA in your cells. That's that's my take-home message that I want people to walk away from. And if you time out my elevator pitch, the whole thing is about 1 minute. So I still get to that why should you care at the end of the 1 minute. So if you have 2 or 3 minutes, you still need to get to that at the very beginning, and then you can continue on with details after that. Does that make sense? Okay. So again, these are just the general rules to follow. Biggest one is just in general, know who your audience is. And then define the 2 rules I always follow is define one takeaway message that helps you center your entire talk around that one takeaway, and then know who your audience is. And if you can think of a useful analogy. Yeah. You can do that at the end as well. Again, there's no, like, these are just general rules. There's no hard and fast. If you want to re-emphasize it at the end, at the beginning and the end, that's totally fine. It's whatever is comfortable, whatever you find gets your audience interested. Okay, so we're gonna do a practice. So this is text. This is an abstract from one of my friends' research in graduate school. And it's the reason why I chose it is because it's a very short abstract compared. It looks like a big block of text, but it's actually a relatively short abstract. And I know the research well, so I can help guide you through it. But knowing this, we're gonna condense this really scientific thing into something that's feasible for a general audience. So I will read this, and I don't expect you to actually understand all of this, but I'll read this and then we can walk through it. So we have constructed a 26 amino acid transmembrane proteins that specifically transform cells, but consist of only 2 different amino acids. Most proteins are long polymers of amino acids with 20 or more chemically distinct side chains. The artificial transmembrane proteins reported here are the simplest known proteins with specific biological activity, consisting of solely an initiating methionine, followed by a sequence of leucines and isoleucines, 2 hydrophobic amino acids that differ only by positions of a methyl group. We designate these proteins containing leucines and isoleucines as little proteins. These proteins functionally interact in the transmembrane domain of the platelet-derived growth factor beta receptor and specifically activate the receptor to transform cells. Complete mutagenesis of the proteins identified individual amino acids required for activity, and a protein consisting solely of the leucines, except for a single isoleucine at a particular position, transform cells. These surprisingly simple proteins define the minimal chemical diversity sufficient to construct proteins with specific biological activity and change our view of what can constitute an active protein in a cellular context. So I know not everyone is a biologist in this room, but first of all, we're gonna just, take a second to absorb what I just read if you understand it at all or not, but take 1 second and think about, I'm gonna define the audience for you guys as the general audience, which is at about a high school level of understanding. Okay, so someone who may understand this, which I can help you too, what is their takeaway message from this abstract? Yes. Yeah, so a lot of people don't know what a protein is. Yeah, so what you just said, sorry, I had to repeat for the microphone. So what you said is, if I'm repeating you correctly, is that most people don't know what a protein is, and so you have to describe that a protein can be made out of a lot of different components, and they're trying to figure out which of these components are actually important for its activity.
So someone online said
reduce the complexity from 26 to 2 proteins and repeat the same process. So, thinking about that, so their takeaway message that they wanted you to get is, is basically this last sentence in their entire abstract, which again, is the opposite way of what you should be doing for general public. So they had all this detail, and their last sentence is that they found a very simple protein that has a simpler protein than anyone else can think of that ever had, that actually has chemical activity on a cell. Their takeaway message. Okay, so can you guys think of, we can try this, but can you guys think of maybe a useful analogy to describe what a protein is, since that's one of the more complex terms that you really need for people to understand, or what they're trying to do. So I will do a quick explanation of what they're trying to do in this. So proteins are these I'm trying to do it without giving away like the whole thing. But basically they have basically a computer code essentially, and they're trying to figure out what the minimum number of characters in this computer code would be needed for it to work. And I just used an analogy to make that work, to make the cell react to it, basically. The protein is the final product of your DNA, maybe. So what I like to use for proteins is actually, I like to say that they're little machines in your Lego blocks. Yes, Lego blocks is also a good analogy. So let's go with the Lego block analogy because I kind of like that. Okay, so if you're trying to explain how you can make Lego blocks, so yeah, assuming that proteins are a combination of different Lego blocks and how you build them together has different functions, which I think people can understand that. So having combining different Lego blocks together can have different functions. Essentially what they're trying to do is trying to find the simplest combination of Lego blocks to be able to have the same activity as something that's really complex. Does that make sense? So can someone think of a way to now turn that into a little bit of an elevator pitch style? Like what would be a kind of a clever, fun lead-in that you could do with that? Yeah, I know. And anyone who's connected remotely can just type in any ideas that they have, or if they have a pitch they can think of, they can type it in. But yeah, I'll give you guys a minute to think about this.
Can you build a Lego castle with just 2 types of blocks?
That's pretty good. Can you build a Lego castle with just 2 types of blocks? Yeah.
As a kid in Christmas, you might have gotten super excited.
Actually, I'm gonna, sorry, so I don't have to repeat you. I'm gonna actually have you hold the.
As a kid in Christmas, you might have gotten super excited getting a huge Lego set to build a Millennium Falcon or a castle or something else. Now imagine only using 2 types of those pieces to build your final product.
That's pretty good. I like that. And then you could go on and explain that, well, that's basically what we're doing in cells. We're basically trying different types of Lego blocks, which are proteins. And you can use some jargon when you're talking about it, you just had to define it. So yeah, so I like that. That's really cool. I like that analogy. And it ties in things that people might geek out and nerd about too. We actually have a Millennium Falcon at our house, Lego Millennium Falcon at our house. So but yeah, so I like that. So then you could lead it, that's your analogy. You could have, again, you can start off with anything. You can start off with your analogy. If you wanted, you could start off with like your big picture of like, I found the smallest combination of Lego blocks or something. Again, and then just at the very end, then tie this into, again, why before the last minute of it, why should they care? Why does this matter? In the context of this research, this is very, very basic biology research. So there is no like direct health application, which in biology, we do have the cheat that we usually can say there's some sort of health application, even that's not what we're studying. So there is no direct health application, but this expands our knowledge of understanding everything in biology in general. And you could do the cheat if this expands our knowledge of diseases, because it will very distantly. But does that make sense about thinking about how you should think about your own research with this example that you may not be familiar with? Okay. So again, now we're going to go through this with your own research. So for you guys, for FRIPS, your audience is already defined. Again, we said that it was for a general scientific audience, not a general audience, but general scientific audience. So they might have a little bit more knowledge on the science behind it. So usually when I think of general scientific audience, I define of like college level of science, not a specialist in your field, but assume someone who didn't major in your field, but as a scientist. So they would have, so me as a biologist, I did take physics classes, so I do have college level physics, but I don't have obviously quantum and all the, all the crazy physics. I did take chemistry courses and everything, but I didn't take really advanced chemistry, like physical chemistry sort of thing. So think about it at that level. Someone who isn't your field, what were the minimum requirements that they had to take in college? All right, so now I want you guys to think by yourselves about your research. If you're giving an elevator pitch and you have one takeaway message, give yourself a couple minutes right now to think about your one takeaway message. If you have something to write it down on, write it down. But what's your one takeaway message for your research? We'll just do it. I'll give everyone a couple more minutes to wrap up their thoughts on what they think their takeaway, what do they want people to actually take away from their talk? Okay, and then once you guys have that, then can you guys think of your own research? Is there a useful kind of neat analogy or something that you can use? And we can, if people online, again, you can comment in the Zoom comments or here in person, just if you are struggling and you want to speak up and want help, we can brainstorm this together since we have a little bit of a smaller group think of an analogy for your research. But this is time for you guys to think about how you would want to communicate your research. And we're here to help you guys and we can brainstorm as a group too. And if you're thinking of your analogy, also think of how you want to lead into that analogy or into your big picture. So, yeah, you have an idea? Do you want me to hand you the microphone? So. Yes.
So my work tries to update the picture of a cell, and I work with new and very high resolution microscopes to see how the different parts in a cell can dance with each other to achieve a normal cell function.
So, okay, so what are your challenges that you're struggling with that?
Trying to say why is that important to like change the cell picture to what we see on the textbooks now and what is really happening inside.
Okay, so your challenge is you're struggling with trying to say why is it important that we need to change the picture of the cell from what it is in textbooks to what it actually is. Okay. So does anyone have any ideas for why that would be important or how? You could lead off with, or go ahead, sorry.
Yeah, like how if we know that different parts of the cells have to work together to make the cell function correctly, if this doesn't happen and they are isolated, then cells won't function normally and the organs also.
So if we don't know how the cells are organized properly, we don't know how they actually function. Is that what you're trying to say? Okay. So I'm thinking, so my thought would be you could start off with, so your big takeaway is we need a new picture of the cell, right? That's your big takeaway message. So how you could lead in is you could lead in with a question of, well, did you know that the picture of the cell that you're used to seeing from textbooks is not right? Like lead off and make them question about what they know about their knowledge. And be like, yeah, that's actually not the right picture. And that's what I'm trying to do is I'm trying to figure out what the right picture is. Does that make sense? And then like the greater implications of that is then, yeah, so if we know what that actually is, we know how everything works, and then we can understand how to, again, the biology out, we know how to cure disease. But does that work? So you could, yeah. And then you can think of, right now, you could think about just like ideas of how you can expand that and everything. Cause I think you guys have 2 to 3 minutes, so you can give a little bit more detail in that, but that's a way you could lead in, just to kind of ask that question of like, did you know that this isn't actually the correct picture? Anyone else have ideas that they want to? Yeah.
So I'm an atmospheric chemist, which means I'm trying to understand what the emissions are from various activities and how that impacts air quality. My kind of analogy starting off question I thought of is, if you wanted to make bread but don't know the ingredients, how will you make it? Which in turn leads into me trying to understand what the emissions are and how that leads to the poor air quality that prematurely kills 300 to 700,000 people a year.
So did you want help on, I think that sounded pretty great. Yeah, that was pretty good. So if there's anyone who is connected remotely who wants to, they also, like I said, you can unmute yourself on your Zoom, and if you want to speak out loud on the Zoom through your microphone, we can make that work as well. Yes.
How should you structure your elevator pitch if you have worked in different fields? Should you even attempt to talk about 2 fields or only talk about the current one?
It depends. If it's an elevator pitch where you only have like 1 to 3 minutes, I recommend you like I said, you only really get one takeaway from that. So pick one in that sort of in that context. If you can, I don't know how similar your fields are to be able to combine them, but usually you want one takeaway. So whatever the one takeaway you want, that's the field that you would focus on for that. And then hopefully the idea is, with the whole idea of an elevator pitch is to get someone interested enough to want to ask questions. And then you can start having a conversation with them. And that's when you can talk about your other field. But again, there's no hard and fast rules, but that would be, in general, one takeaway, so.
I guess I can customize elevator pitches for the different companies at the summit.
Yeah, yeah. Or I guess someone here is from the actually organizing it, so you can speak about.
So during the actual competition, you're going to be presenting to all the industries within that field at once. So you'll have the 2 minutes to present everyone that's, if you're in physics, in the physics field, if you're in aerospace field, if you're in biology, the biology field. However, there are going to be other times that you can be speaking to the individual industries, and at that point you can have these specialized elevator pitch for them, because we'll have a speed networking event from 2:30 to 3:30 and then a social networking event from 5 to 7. But for the actual competition, you have to make it as general for all the industries within that one field during the 2 minutes.
Yeah. Well, so to add on to that question, I guess, how can I ask that person? So to the person who's asking about the 2 fields, how closely related are your 2 fields? Optics and radio frequency. Wireless. And so yeah, it is on the electromagnetic. Yeah, I get. Yeah, that would depend on your specific research. If that person who is I obviously I don't know who that person is, but if you want, we could work together right now to be able to work on this. You can, again, turn on your microphone and we can
We
talk.
also had someone else contribute, so that
Okay.
might be something.
Yes, okay, what was the other question?
So we had someone else write in. Can you hand me the microphone?
Yeah.
I mean, they can read it in the chat, but then we don't have to repeat stuff. So who said, I work on landing techniques for the Mars mission. It's kind of like driving a car down a tall mountain so that you end up in exactly the right parking spot, but the car is low on gas, has bad brakes, and you can't ever stop.
That one is pretty awesome. Yeah, I like that one. That one is actually a pretty great analogy. So for the person who has the two different fields, we can work together. If you wanna, again, if you wanna unmute yourself and you can chat, and hopefully we have loud enough speakers, we can work on it together. Or I will put up my contact information afterwards, and Ellen and I are more than willing to work on these with you guys afterwards as well if you want to contact us, because the radio frequencies and optics. I guess I don't know your research specifically to know how we could tie them together, but like again, it's a very case by case basis to know. But
Yeah, so he says he doesn't have a microphone.
okay, so just contact. I will put up my email address in a couple slides, and
I just said that goes for chat later.
yep, yes, yeah, that's for everyone. I'm more than willing to work with people afterwards. So I do phone calls, emails, whatever, every tech we have. So let's see, what time is it? Okay, about 10 minutes. So I actually wanted to leave the last like 5-10 minutes for any other questions that you guys have. And if anyone wants to ask questions about their research again, or wants to workshop it a little bit with the group.
If you're not in a situation like FRIPS, where like industry or whoever you want to talk to scare everybody, how would you approach someone before starting?
So, okay, the question is, how do you how do you approach someone to even start an elevator pitch if it's not a set thing like FRIPS is, where you're like giving it in front of an audience? So a lot of times I've given my elevator pitch to friends who are like who are my husband's friends, who don't know that what I did for research, and they ask me that a lot of times the question comes up, so what do you do? And that's the biggest time I usually give an elevator pitch, is when I get asked from someone, once they find out I'm a scientist, they go, so what do you do? Or what do you study? That's usually the biggest. It usually comes from them, starting from them, and that's usually the type of question that leads off. Or if you're on an airplane, yeah, if you're stuck next to a chatty person on the airplane, someone usually asks. I like I said, the context that I usually have gotten it in is by friends of my husband or something. But I also in general, just like people I start having conversations with. I've actually talked about my research in line at a coffee shop. If you get in conversations with people, that's usually the context that I have an elevator pitch ready for. I also have, like I said, when I was a graduate student, I also had a scientific elevator pitch that was a little bit higher end for when I would go to conferences. So that's another type of elevator pitch that you should have ready. That's not to a general audience. That's for if you go to conferences, but those conferences are usually in your field, so they can be a lot more jargony than if you're trying to talk to a general audience. But overall, keep these messages the same. Like, know your audience, and even if you're giving an elevator pitch to someone who's a scientist, still try to lead off with the cool thing that they want to know about first. Yeah. Okay.
So if you're doing an academic job interview and you're at the institute for the in-person interview, and the department you're interviewing in is kind of a broad department, so they don't specialize in just what you're doing, but they have people in a lot of different areas. You want to have 2 elevator pitches, one for the people that might not specialize in your area, and then one more specialized for people in your area. And then should the elevator pitch be more focused towards the research you're proposing to do in the department, or the research you've already conducted?
Ellen wants to answer this one.
So this is Ellen. I was on a lot of search committees at my previous job, which was as a faculty member at a liberal arts college, which had most of the departments were a variety of people. So I would say if you're on an interview, you probably won't be giving elevator pitches. You will be giving a research talk. And I would say, you know, the department should tell you what the audience for that is, and if they don't, you should ask. You know, are they inviting undergrads? Are they inviting people from other departments? And that should give you an idea of your audience. I think I would say you don't really, I wouldn't worry too much about preparing a specific technical elevator pitch, if only because you're naturally going to be better at talking about your work to someone who knows a lot about it. I do think it's worthwhile to prepare a few minutes, you know, maybe not an elevator short, but something that is more general. If they have you meet with the dean or the provost or the president of the college or something like that, those people are not going to be in your area, and being able to talk about your research, both your background and sort of any research that you're planning to do is going to be important. Oh, sorry, someone asked me to repeat the question. So I apologize. Sarah was really good at that and I screwed it up. So they were asking about if you're on a job interview and the department is everyone is not all in your field or in your subfield, do you prepare sort of two versions of a talk? I think the other thing I would say, and Sarah might have some advice here as well, that the more you do and prepare different ones, it gets easier to translate in between them. So you're not sort of, oh, I have 7 different versions of this. It's sort of, you get to the point where you can kind of tweak it a little bit. So we did have a couple of other questions here. So I'll just read them out because I know you guys, the remote people, can read the questions. But so someone asked, I work on risks and benefits of cannabis use and often feel that anyone who does not use or want to use cannabis does not relate or care. Does anyone have ideas of how to draw those folks in? I was thinking, and I'm not a biologist, so I don't know, but if you talk about it just like any other medication, that might be a way to sort of generalize that. But
so the comment was, even if the person you're talking to is not using, more people around that person are starting to use it. So understanding and knowing what the risks and benefits are to the people around you is also important.
We're also kind of related to other drugs that are we're starting to learn the unfortunate risk behind them, like the opioid crisis right now, and there might be benefits or other different risks with marijuana that we haven't gotten money to understand and need to understand, or
so yeah, the comment was comparing it to essentially other drugs that we are very well known and used right now, or like the opioid crisis. We didn't know all the risks about that when it was very started being heavily used, and so the more we know about marijuana, we can maybe avoid some of those risks. Paraphrasing, sorry.
The person says thank you. So, and then we had one other question. Do you ever mention your skills explicitly in the elevator pitch, or are they implied while you are describing your work? So yeah, I would say no, unless it's relevant, because I mean, in this case, you know, yes, you're talking to people who potentially might want to hire you for a job, but the main point of an elevator pitch isn't to sort of get a job, I guess. I don't know. You might have other thoughts.
Again, this goes back to your audience. If you are, I rarely ever mention like my specific skill set when I give an elevator pitch. There just usually isn't time. However, when I used to talk about my research to a little bit more of a technical audience that might know, I might talk about how I actually did develop an entirely new system to be able to study mechanical properties of a cell, and I might talk about the optics that I used and like that sort of thing. Again, it depends on your audience. For a general audience, usually no, I don't go into that. For a more scientific audience, and usually it's a scientific audience that I know will know what I'm talking about. So if I drop optical tweezers on someone, like that person, that's a term I don't drop on many people. I would want them to know that that's something that I already know that they know that sort of thing.
Someone else had a question, a general question that I think I have is about advice for trying to come up with analogies.
Advice for coming up for analogies. Again, my experience is in biology, so that's where my primary experience is. I have helped people like come up with these in all different sorts of fields, but I'm trying to think of generic advice for what I've used.
So how do you start? Like, do you start from really thinking about what your work is specifically, or do you just start thinking about general things around you to see if any of them?
I would start with it.
Yeah. Yeah, okay, so there's a lot of questions and comments here. So the comment was, the question slash comment was, do you think about big things around you that could maybe play in, or do you think about something very specific? When I've done it in the past, I tend to take a more general approach. And Ellen had a comment of like, start thinking about your takeaway and what you want them to take away. That's a good thing. That's the one thing you should focus on. What's the big thing I want to take away, and work your analogy usually around that. But yeah, when I think of when I've luckily been fortunate in my research that a lot of it has always been very physical things. Like I've always studied something mechanical, so there's always usually some sort of analogy, mechanical analogy to that. If you can't think of an analogy, isn't always important. If you can't think of one, just make sure that you can describe it in a way that someone can understand. An analogy is just a really easy way to paint a picture, but not all analogies work perfectly, which is why it's a general rule, but it doesn't always work. If you can relate your research to some sort of tool that could be used that, that can do something similar, that's always a good way to think about it too. But, and again, and then again, if you are struggling with your analogies and you want help, I will just put that screen up right now.
I also checked our addresses.
Okay. And the biggest thing is practice, practice, practice. You heard me try to do the hard and the medium of my graduate school work. So I have been out of my graduate school for over 3 years now. And so I haven't practiced those. This is like one of the first times I've actually said them since I was in graduate school. And you could hear me struggling because like, oh wait, I haven't done this in a while. So practicing it makes it easier. And what Ellen was saying earlier, the more you do it and the easier it is to convert between different versions, to have ideas of how you can change it up. Because again, it's just, oh yeah, this audience, okay, I need to emphasize this. Okay, this audience, I need to emphasize that. The more you do it, the easier it becomes. And
We'll have a link for this so that people can access it later.
yes, and then so we will be putting this on YouTube, and so we'll create a link and we'll send that out to you guys by the end of the week. Yes.
We have everyone that's registered, and we'll send a link out to everyone that I'm not going to be able to attend today, and then there will be a link for it also through the FRIPS webpage.
Yes. So yeah, the link for this this will be sent out, so you can rewatch this, and you can get our contact information from this on there, and then anyone is welcome to contact us afterwards. And if you want to know more about our center specifically and what we do for education, there is our center's website as well. So any last questions? All right. Well, thank you everyone for coming.
Thank you guys for holding this.
Yeah.